Thank you very much. That is to say the Abdulrazak. Before I introduce you to vector calculus and Green's theory and vector calculus. In fact, I have to let you know how to do double integrals and triple integrals. From there, then I can proceed to vector calculus because we shall have what we call Green's theory, which will make use of double integrals and triple integrals. So let's have this type of integral. First one, if you have integral 0 to 3, 2 to 3 of x squared y squared dy dx dy dx dy dx. How do you go by this? Now, what we do is that you see the dy comes first. So the inner one, meaning that the dy moves with integral 2 to 3. You see dy dx is outside, and outside one is integral 0 to 3. So 0 to 3 is for x. So if you want to integrate the first one, you can integrate this by taking x as a constant because it is dy. You are integrating 2 to 3 with x squared as a constant, but integrating y here. If you want, you can rearrange it. You can rearrange it by making, if you rearrange it like this. This one is x, so it should be integral 2 to 3, which is the y1, integral 0 to 3, which is for the x squared, y squared. Then it means that you have got the x which is outside, inside. So means that the x which is outside will come here to be dx, then dy. So you can integrate this x first with the inner, and 2 to 3 dy outside one, or integrate this one 2 to 3 with the x squared y squared dy with the y where x squared will be x will be constant. So you can choose to do it this way, the same way, or rearrange and integrate. In all, you will have the same answer. Again, I'm saying dy. You see, dy is inside. So it means that it goes with integral 2 to 3. So dx is for integral 0 to 3. So you integrate from the inner one. So the inner one means that if you are integrating with this one, it will be 2 to 3. x squared y squared dy. X will be a constant. But the way I rearrange means that if I am integrating, I could have stayed here, integrate it, or rearrange it based upon your preference. It's a choice. Now, if I'm integrating this, means that it will be integral 2 to 3. I will integrate 0 integral 0 to 3. This one is outside. X squared y squared dx, which will be inside, then dy will be outside. Dy will move with 2 to 3, which will be outside. Now I'll pick the inside one. I'll pick the one inside. So it will be integral 0 to 3 x squared y squared dx. This is what I'm integrating now. So that when I finish, I'll come and put it inside. Then we'll go with this 2 to 3 of dy. Now if I'm integrating this with dx, it means I'm picking y as a constant, but integrating what? X. So in that case, I will get, if I'm integrating, because the power is 2, so I'll get 1 over 3 x to the power 3 y squared. No, so then x is equal to 0, x is equal to 3. You see that? The reason why I rearrange is that dealing with 0, it will be very easy with 0. After that, I will get very humble algebraic expression to substitute. Now, this will give me You are substituting, when you substitute 0, the whole thing will be 0. So substitute 3. Give me 1 over 3 times 3 to the power 3. Not so. Y squared, because y is a constant. So this will give me 3 to the power 3 is 20. Is it 27? 27 divided by 3 is what? 9. So this one will give me 9y squared. So when I integrate this, s squared y squared dx 0 to 3, it will give me 9y squared. Now I'm coming to fix 9y squared inside this. Inside is what I've integrated. This one is for the inside. Let me indicate it. This one is for this. So I'm coming to fix this one there. So that it will give me integral 2 to 3 9y squared dy. You see, I have gotten simple integral to integrate. Very simple as that. That's how you go by double integrals and triple integral. It is not anything difficult. It's very simple. But their application in line integration and then integral vector calculus isn't that we shall face some level of difficulty because we need certain level of planning and thinking. Now, this one. This one is integral. Okay, let's integrate. Will give me 9 over this one. The power is 2, so it becomes 3. Not so. Y to the power 3. And this y is equal to 2. Y is equal to 3. So that this one will get 3 y cube. With y is equal to 2, y is equal to 3. Not so. Now let's put the values inside. It should be 3 times 3 to the power 3 minus the lower limit, which is 2. 3 times 2 to the power 2. So this one will give me 8. 3 times 27 give us what? 81 minus. This is 4. 4 times 3, 24. 81 minus 24, 57. So, with this, you can choose to rearrange. So, you see that here it is 2 to the power 3. 2 to the power 3, which is 8 times 3, 24. So, 81 minus 24 gives 57. And the same answer as when you go to arrange. So this is a way to go about when you are giving double or triple integral. Then let's go to a triple integral. This triple integral. So we see which one is the inner one? The x move for this. The inner one. The y move to 0 to 3. I'll rearrange them so that I will integrate them comfortably. I will rearrange them. But I will arrange them here. I will have, it is integral 0 to 3 of integral 0 to 3, integral 0 to 2, integral 1 to 3, xy plus 2. Xy plus 2 plus z. Xy plus z. Plus z. Dx, dy, dz. So mean that if I pick the inside one, it should be integral 1 to 3. So if I'm integrating, I will integrate 1 to 3 of dx. Then I come and pick whatever I get into integral 0 to 2. Then solve whatever I get integral 0 to. But I will arrange them so that I will solve the zeros one. The one with because the zero, the lower limit will give me 0, so I will only substitute the upper limits inside. Things will be very easy. This one will be integrate dz first, then come to dy. What is it? So I will rearrange. I will get integral 1 to 3. As for dx, I will integrate the latter part. Integral 0 to 2. Integral 0 to 3. And 0 to 3 is for dz. So x, y plus z, dz. Then integral 0 to 2. 0 to 2 is for dy. So I'll come dy. Then 1 to 3. 1 to 3 is for dx. So dx. So this is how I have rearranged these integrals to integrate. But I think if I can clean this side so that I integrate. Yes. Let me clean this side. So that this one, this integral 0 to 3, integral 0 to 2, integral 1 to 3 of xy plus z dx, dy, dz. I've rearranged them to get integral 1 to 3, integral 0 to 2, integral 0 to 3, x plus y, xy plus z dz, dy, dx. So this is what I have to integrate. But I have just rearranged this one. You can start without rearranging it to integrate 1 to 3 of dx so that y and z will be constants. You will pick them as constants. So for this, I will integrate this first. You see where I have marked with the red marker. I will integrate this first. After that, it will come inside this one. I will integrate integral 0 to 3 xy plus z dz. So I'll write integral 0 to 3 xy plus z dz. I'm integrating with respect to z, so x and y will be constant. No, so that if you integrate a constant, for example, if you integrate 2, it will give you 2x. No, so if you integrate a constant 2, it will give you 2x. So this will give me, if I integrate it, give me x, y, z. Plus, here will give me 1 over 2 z squared. Because the point here is 1. You add 1 to the power, divide by the mean power. Z is equal to 0, z is equal to 3. So that when you put whatever you see z3, because 0 will render the whole thing 0. So here will be 3xy plus, here 3 squared will give us 9. Not so? 9 over 2. 9 over 2. No, so we got this 3, 9 over 2. Here will give me 9 over 2. Is that what it is? So mean that when I integrated this, it gave me 3xy plus 9 over 2. If that's the case, that will take the model here. So it will be integral 1 to 3, integral 0 to 2, 3xy plus 9 over 2 dy. You see that what happened to dz? Now dy dx. So what is it? Did that bring plus? So dy dx. You see that? Now I will integrate now integral 0 to 2 of 3xy plus 9 over 2 dy. So I I am integrating this. I am integrating this. With respect to y, so the x here will be a constant. Now it will be integral 0 to 2 3xy plus 9 over 2 dy. Not so? Very interesting. Very interesting indeed. Now, if I integrate with respect to y, x will be constant, not so? X will be constant. So that this one will be, if I integrate here, this one will be y to the power 2, not so? The y will be power 2 and divided by the new power. Because so it will be 3x y squared, this one over 2. Plus, if we integrate 4 with respect to x, 4 is a constant. Integrate 4 with respect to x, it will give you 4x. If you integrate 10 with respect to x, it will give you 10x. So that when you differentiate 10x, it will give you 10. So when you integrate 9 over 2 with respect to y, it gives us 9 over 2y. Integral, the limits are y is equal to 0 to y is equal to 2. Fixing in, we get after 0, everything will be 0. So that's why I started at 0 first. That's the reason I rearranged. I did the rearrangement. So that this one will give me, put it through here, y. So this one will give me 3 over 2x times 2 squared plus 9 over 2 times what? 2, not so. So that 2 squared will give me 4. 2 goes to that 2, that 4, 2. That 4, that 2 more plus 3 will give me 6x plus. This 2 will cancel this 2, give me 9, not so. You see that? Let me check well. 3 over 2 times 2 squared because the limits are 0 to 2. As for 0, will give me 0. Anything subtracted from 0 will give the same thing. So 3 over 2, x, y is 2. 2 squared 4. This 2 goes to the 4, 2. 2 times. This will give me 6x plus the y, 9. So that this one, you see the whole of this, what we have integrated now, what you have integrated, the inner one, is 6x plus 9, which will go with 1 to 3 dx. Now that one, even S students, fresh S students with a little of calculus can integrate that one. So that will be integral 1 to 3 6x plus 9 dx. Now when you pick them gradually, you remove them like that, taking them as constant. So that this one will give me, if we integrate this one will give me 6 over 2, not so, x squared, because you add 1 to the power, plus 9x. X is equal to 1 to, is it 1 to 3? You see that 1 to 3, you see that the elements, I will subtract the elements. When I start from where the elements are 0, you see that I have it very easy. That's how it should be done. Now, when x equals to, this x is equal to 3 to x equals to 1 to x equals to 3. 6 over 2 times 3 squared plus 9 times 3 minus 6 over 2 times 1 squared plus 9 times 1. This one, 9 squared, 3 squared is 9. So 9 times 6 3. So 9 times 3 also
27.
27 plus 9 times 3.
27.
So 27 plus 27 also minus. Here 2, here will give me 3. Say that by 2 is 3. So 3, because 1 square is the same. 3 plus 9. So this one will give me, 27 plus 27 give me 54 minus this one give me 12. And that finally gives you 42. So when you integrate this triple integral, the answer will give you 42. So I hope you can do same to this one. This one becomes easy. But this one is so very easy. This one you pick integral 0 to -2. What will be first for the dx? Not so. For the dx. Integral 1 to 3. This one I won't finish. I will let you continue. For this one is very simple. Having explained the first, second, and third, you go and do that one. So that you will facilitate your understanding. For this one, this is x plus y dx dy. So that when you pick the inside dx, the dx goes with this. So that it will be integral 0 to -2 x plus y dx. You pick the y as a constant, integrate x. It should be 1/2 x squared plus xy. Because if you integrate y a constant, you give it xy. Just like if you have 10, you integrate with respect to x, you give it 10x. So here 0 to -2. So that this one will give me 4. No, so 2 square will give me -2 square will give 4. And the 2 will cancel there. 2 will give you what? 2, not so. Plus minus 2y. Not so. Because x is 2. There's 2y. So you put inside this. So finally you have integral 1 to 3, 2 minus 2y dy. This is simply SS integration. Thank you very much for watching Fuseli Abdullah at Ninja Mind. Follow me on Ninja Easy Mathematics. You will get more videos online integration. In fact, subscribe and have all my videos. You have vector calculus, Green's theorem, in fact, a whole lot of theorems